Well, thanks, Julia. Thank you all for coming along today as well. I certainly couldn't resist the chance when I was invited to give a Rare Bites talk to talk about a snakebite topic. And so if you'll pardon the pun, I wanted to say thank you for the invitation. Let's hope I can go uphill from there. Look, I think Frank Tidswell's book is not so much a landmark in medical history as a bookend, and that's very much how I see it. I see it as a book that marks off the end of a particular colonial way of understanding venomous animals and medical problems more broadly in colonial Australia, and starts to illustrate the stirrings of what these days we call biomedicine, a different way of extrapolating from animal experiments in laboratories to clinical medicine, and that's definitely not the colonial mode of conduct. Now, it's a fairly small book. It's about 80 pages long. Again, please feel free to enjoy it after I've finished. But it was Tidswell's attempt to collate as much knowledge as he could in this new modern mode, which meant that he dismissed a lot of the older work out of hand as well. So it really is a compendium of his work and a few other bits and pieces published at the start of the 20th century. Broadly, it encompasses what we might call statistics, although really they're just collated data. There's no statistical analysis in there. A range of his experiments, which for me, as somebody who studied pharmacology many decades ago, I can understand completely because it's fairly basic experimental pharmacology, as well as his attempts at creating some new therapeutic measures, particularly antivenenes, or what we now call antivenoms as well. Most of the book focuses on snakes, as you won't be surprised to hear. There's a reasonably solid section on platypuses, which I'll touch on briefly, but feel free to jump in at question time and ask more about that. And then he finishes up on what these days we call the redback spider. Interestingly, Tidswell left out paralysis ticks. I find that strange because they were starting to be a clinical problem by the time he wrote this book, and he studied tick fever in cattle, and yet he pointedly didn't study the issue of paralysis ticks. That was later studied really by a different group here at the University of Sydney in the 1920s. Now, what we know about Frank Tidswell comes largely from the work of the late Peter Tyler. Tidswell was the son of a rural pub owner. He was born in 1867, and then he came here to the University of Sydney where he studied medicine and then later worked as a resident medical officer at Royal Prince Alfred Hospital just over the way. But he couldn't keep away from the university, and he was particularly drawn to this chap here on the right, Charles, or C.J. Martin. Now, Martin was the demonstrator in physiology here at the university, and Tidswell started working with him particularly around snakebite, but also around platypus venom as well in the mid-1890s. And Martin, in the 1890s in Sydney and in Melbourne, inspired a whole new generation of what we these days maybe would call medical investigators. And Tidswell was certainly one of those who were infused with what came to be known as the Martin spirit. And in fact, the National Health and Medical Research Council still has the C.J. Martin Awards for really outstanding medical researchers, which gives you some hint of his long-standing impact on Australian medical research. Now, in addition to his laboratory work at the university, Tidswell was also taken by modern bacteriology. And so in 1895, he was appointed to the Board of Health, which is a New South Wales body. And in 1908, he helped set up, in fact, he campaigned to set up a new sort of proto-medical research institute called the New South Wales Bureau of Microbiology that ran from 1908 to 1913 before it shut down. Now, one of the reasons it shut down was the same reason that Tidswell was shut down, was that he was headstrong and opinionated, and he didn't sit very well in a public service culture. So by the start of the First World War, he'd annoyed enough people and they'd annoyed him enough that he actually pulled out of medical research and went and worked in clinical medicine pretty much until his death in 1941. So it's a bit of a shame for Australian medical research, but what that means is that this book, Researches on Australian Venoms, also fits into perhaps the most active phase of his investigative life as well. I think the question arises though, why would somebody like Tidswell, who's drawn to modern medicine and all the challenges of combating infectious diseases at the end of the 19th century, why would he be interested in snakebite? Well, it still was a major cultural and to some extent clinical problem at the end of the 19th century, particularly in country areas. Remember, he was of course a rural resident originally. But also in this period, the 1890s and the first decade of the 20th century, snake venom was actually at the forefront of experimental physiology, experimental biochemistry, or what was known as physiological chemistry at the time, but also in the new science of immunology as well. And so serum therapy and particularly treatments for terrible diseases like diphtheria, for instance, was developed hand in hand with the first antivenoms, or what these days we call antivenoms as well. So this work was actually very much on topic, and it connected with scholars not only in Australia but in the United States and France, India, and in French Indochina as well. So you see that throughout his text. He's actually conversing with the latest in these scientific developments, and particularly this new mode of treatment, immunotherapy. Nevertheless, in the book, Tidswell admits that compared with infectious diseases, which were killing thousands of Australians each year, snakebite was not a major epidemiological problem. Now, whenever I present data from Colonial statistical analyses, I always say it's a pack of lies. Don't trust it very much. Honestly, these are indicative, but what they give you a sense of is what people at the time believed. And I think that's an important distinction from saying these are actually true data. Now, if you look on the graph, the red line at the top is multiplied, but it broadly represents the growth in the Australian population from 2.2 million in 1881 to 5.5 million in 1921. In that same period, the blue line shows you the drastic problem of snakebite across Australia. So it was almost nothing. You know, there were 10 to 15 people dying across the entire continent per year in this period. And in fact, if you want to know who the typical victims were, have a look what happens through World War I. When you send your young men away overseas for 4 years, suddenly the snakebite death rate drops dramatically. So it was young men, alcohol and sticks were a problem then, and they continue to be a problem now. So although it was a minimal clinical problem, there were lots of snakebite cases, but in terms of death rate, it was almost nothing. But in Tidswell's words, there were few accidents more distressing. And again, in his words, victims presented the pitiable extremity of terror. You know, there was a genuine popular dread of dying from snakebite, partly because the death rate was seen to be so high. One of my arguments for the fact that this was a cultural as much as a clinical problem comes from the fact that from 1891 in New South Wales, the police were given specific instructions that they were to collate reports of every snakebite that came to their notice. And so they had quite a large body of snakebite reports that came into Tidswell's analysis. He added to that records from the government statist, and also he went through the colonial medical journals, particularly the Australian Medical Gazette, to find additional case studies. And he came up with about 190 case reports that he felt were reliable enough to analyse. Now, partly the reason he did this, and I'll come back to this, was to try and work out what might be rational first aid for snakebite. But he was also interested in which snakes were deemed to be responsible for the most deadly bites. In 1898, Edgar Waite had published a new book, the Australian Snakes, which said that there were 5 fatal snakes in this country: the copperhead, the brown snake, the black snake, the tiger snake, and the death adder. And particularly the black snake, which we see in the middle here, the red-bellied black Pseudechis porphyriacus, was demonised through the 19th century as the most deadly snake on the Australian continent. And so, for instance, Charles Martin and Tidswell, when they'd been doing venom research in the laboratory, had focused very much on black snake venom, precisely because it was seen as the most dangerous snake in the country. Well, what happened when he actually studied these data? I'm glad you asked. Another slightly complex slide, but what I've shown here are 2 sets of colonial data. In green, you can see Tidswell's results, and then there's another set from the 1920s. So broadly, Tidswell fits into the larger understanding of which snakes were dangerous. And we can see coming in from the left here, case reports of black, brown, tiger, and death adder bites. But don't forget, over on the right are the number of people where the snake wasn't identified, and that is an ongoing clinical problem as well. But when he came to analyse the fatality rates, Tidswell found something very interesting, that roughly 50% of people bitten by a tiger snake or a death adder died. But a much larger number of people were bitten by tiger snakes than by death adders. So he decided, quite reasonably I think, that the tiger snake was the deadliest Australian snake, and that affirmed his laboratory experiments, which showed that its venom was incredibly potent. And in fact, it was so potent that he made a gambit and said, this is the deadliest snake in the world, gram for gram in its venom. And this is the period in which, around 1900, Federation of the Australian Colonies, this is the first time that Australian snakes are being lifted to that global scale of toxicity. Before that, they'd been seen as pretty trifling compared with, say, the cobra in India or the rattlesnake in the United States. The death adder and the brown snake were still seen as fatal, but not necessarily as dangerous. But what was very interesting is if we look at the black snake. 3 times as many case reports and no deaths. So after a century of Australians believing the red-bellied black snake was the most deadly on the continent, Tidswell said, actually, no, we don't actually have any recorded deaths from that snake bite as well. And so he said, quote, that it was not deserving of its present baleful reputation. It was also a bit of an embarrassment for him having done all that work on its venom. Now again, just a point that his data seemed clear, but there was no statistical analysis on this. They're purely quantitative data. So he's making conclusions just by eyeballing the figures as well. So this is one of the points where it's not really modern biomedicine, it's still a rather older model of analysis. Now in the book, and again, do feel free to go and poke around some of the tables in there, he broke down snakebite by the month of the year and seasonality, by the time of day in which people were bitten, and also the body parts on which they were bitten. And all of these seem pretty logical, that people were mostly bitten in summer, mostly bitten during daylight, and mostly bitten on the lower limbs because they either stood on a snake or they were reaching out to grab it or to kill it. Although I'm dismissive of colonial data in a lot of cases, what I do find interesting is that when you look at 3 different sets, and again this is Tidswell's in the green, you find that the gender distribution is quite similar. About 75% of victims are male and 25% are female. And even more interestingly, the death rate in either group is reportedly identical, about 30%. Now, I don't want you to leave here today believing that in colonial Australia, 30% of people bitten by a snake died. This is 30% of reported cases. So a lot of the minor cases and recoveries weren't reported. It's a dramatic over-reporting, but I think there's an interesting consistency within the data that's worth commenting on. On the other hand, the burden of deaths fell very much on the young. So although people under 20 represented half of those bitten by snakes, they represented 2/3 of the deaths. And that was quite consistent with other colonial data as well. Young people, particularly children under 10, died at a much higher rate than adults did. Now, unsurprisingly, Tidswell said, Australians had a great urge to intervene. And he reeled off, as so many others did at the time, this enormous list of potential treatments that were undertaken in the first 24 to 48 hours after a snake bite. People would be marched up and down. They'd have a tourniquet wrapped around them above the bitten part. It would be cut out, or it would be cut into. People would suck it to try and draw out the poison. They'd apply heated cups as another attempt to draw out the poison. They'd douse it in ammonia in order to try and neutralise the venom. Or they'd give them alcohol as a stimulant, like a bottle of brandy. There were children who died from alcohol poisoning because they were given so much hard spirits, because it was seen as an absolute specific. Alcohol was seen to directly counteract snake venom in this period. In addition to all these measures, there were what Tidswell referred to as ineffective barbarities, which included cauterising the bite by applying hot coals to it, putting gunpowder on it and blasting it, and also amputating the bitten part. All of these he thought were ineffective. But the other thing that Tidswell was interested in, particularly from the 1890s, was the phenomenal popularity of pocket snakebite kits. You can see here on the bottom right one that uses the chloride of lime as a potential antidote to snakebite, but especially in the 1890s it was strychnine, which these days we all know is a notorious poison, but it was carried by lay people and injected in increasing doses if they'd been bitten by a snake. Now what's interesting is that when you go back and look at the data from the colonial period, injected remedies, so on the left, the very left, we have intravenous injection of ammonia to counteract snakebite, and the next 3 graphs are different analyses of subcutaneous injection of strychnine. We find that all of those suggested that injecting these sorts of poisons didn't improve the situation. In fact, they tended to kill patients more than the snakebite did. Interestingly, if we look at Tidswell's data, the 2 columns on the right, he said that actually the addition of strychnine had no effect. It didn't change the clinical outcome. So given how poisonous it was, it's probably better not to use it. The one measure he said dramatically reduced death after snakebite was the application of a tourniquet. And so he reiterated the Board of Health's recommendations that we saw on that earlier snake identification chart. Tie a tourniquet above the bite site, cut into the wound and possibly suck out the poison, and apply stimulants like brandy in small doses. I think that what he finally came out and said, more importantly than anything else, is that, quote, but the real lesson to be learnt is when to stop. In other words, don't keep having another go. Tidswell himself didn't stop though, because as I mentioned, he was part of this new era of immunotherapy in the 1890s, turn of the 20th century. Now, this was a period when, for instance, the serum therapy for diphtheria was dramatically reducing the death rate in a horrendous disease that killed large numbers of children around the world. Tidswell was particularly inspired by the work of Albert Calmette, who had been working in Saigon in French Indochina, who produced a serum from the blood of animals that he called Antivenom. In other words, it was meant not to counteract the effects of venom in the body, but it was actually meant to neutralise venom itself. So it was an anti-venom. Tidswell followed the same methodology so that over 1898 to 1901, he took a lame ambulance horse from the Board of Health and very carefully and with great care for this animal, injected increasing doses of tiger snake venom into it until it could withstand phenomenal amounts of tiger snake venom. And from that, he drew off its blood and serum and produced what he declared to be an effective anti-venom in Australian circumstances. The problem was, though, that he said it was so difficult to produce, that it was so difficult to store, and that it had to be distributed around the country, and it could only be used in cases where the snake had been correctly identified as a tiger snake, that again, quote, "Snakebite for the moment is beyond the sphere of practical serotherapy." So in 1906, he'd proven that you could make an antivenom, but he'd decided that it was simply inefficient to try to roll it out on a practical scale. So in Australia, we had to actually wait until 1930 until we had the first antivenom again against tiger snake bite. In the meantime, the older methods, like strychnine injection, continued to be used on a relatively regular basis. Now, just as I round out, I'll come to the last few elements of his book as well. And I think these were all driven really more by curiosity than by any great clinical need. So since its discovery by Europeans in the late 18th century, the platypus had represented an enigma in all sorts of ways. And I think one of the most overlooked of these is this feature. It's the spur on the rear legs of the male platypus that's connected to a duct that produces a very poisonous substance, sometimes called venom, but really it's a poison. Now, through the 19th century, there'd been a range of case reports in humans and also in dogs that when you were spiked by these spurs on the back legs of a platypus, it was incredibly painful. There was a huge swelling and you'd lose use of that limb for 6 to 8 weeks in some cases as well. It wasn't fatal, but it was incredibly painful. With Charles Martin, Tidswell conducted some experiments with platypus venom in a number of rabbits, which died quite rapidly after the administration. And so they said that it's certainly a dangerous poison. And interestingly, they compared its physiological effects with those of snake venom. And I'm interested in that. This may be something to bring up in questions, because really what they were saying was that the platypus had a marked affinity to reptiles rather than the more standard way of representing it as a primitive mammal. Now, another curiosity that he rounds out his book with is what he calls in the introduction the katipo. Anyone here know of the katipo? No New Zealanders. Okay, so in the late 19th century, the katipo was the most feared spider in the world. It lived in New Zealand. It was very similar to other Latrodectus type spiders around the globe, which had gathered a small reputation for being deadly. But in New Zealand, it was considered quite deadly according to Maori law. Those legends translated to Australia, where we had a spider that looked a little bit like this. And it was this spider, what we now call the redback, that Tidswell tried to analyse in the last few pages. The problem is that redbacks are so tiny, he couldn't extract any venom. So he resorted, in his words, to the primitive method of inducing a redback to bite a mouse. What happened? The mouse was fine. So Tidswell's brief conclusion was, as you can see at the top of the slide, that there was an improbability of a fatal issue should a redback spider bite a human being. So he really dismissed redbacks in the final pages of the account. So what did Tidswell's book actually signify in 1906? He affirmed, on the one hand, that Australian snake venoms ranked incredibly highly in global potency scales, if not in the numbers of actual human victims. But much as he tried to collate all of this information and rationalise clinical care and to some extent the cultural response to snakebite, really he didn't change pragmatic first aid. And he certainly didn't change the way that Australians viewed their snakes, which continued to be slaughtered in large numbers until they came under legislative protection in the 1970s, which was when first aid was finally comprehensively revisited. So this is why I think Frank Tidswell's researches on Australian venoms really bookends a particular way of understanding the colonial world, but also gives us a sort of slithering beginning of the modern biomedical world in Australian context. And on that note, I'll leave you by concluding as I began by saying thank you very much. And I'm happy to answer any questions.
Yes. Working? That was, may I say, enjoyable? It's certainly salutary. I wonder, you don't mention the Army, the medical services of the Army, which had encountered snakes in India, particularly, and it was a well-known problem. Is that a feature of Australian medical history?
Yes, okay, that's a good question. So the question is about whether the Army Medical Service was interested in snakebite. In Australian context, I haven't seen any material that suggests that Army doctors were interested in snakebite. But in contrast, as you mentioned, Roy, in India, the Indian Medical Service had a huge interest in snakebite. And so particularly Joseph Farrer, who in the 1860s and 1870s conducted a large number of experiments, collated data across India, which showed that roughly 20,000 people died of snakebite each year in India and Burma together. So it was a huge pragmatic problem in India, mostly amongst indigenous Indians, but also amongst troops as well. Although interestingly, most of their data showed that more British soldiers died of dog bite and rabies than they did of snakebite in India, probably because they were wearing boots and puttees and so on, as opposed to most of the locals who went barefoot in the field. So part of my book, actually a large deal of my book, discusses contrast between the situation in India through the 1860s through to the 1900s and Australia as well, where Indian doctors were completely dismissive of Australian snakes. They thought they were a trifle compared with the cobra and the crate and so on in India. And it was only in this period, with Martin and Tidswell's work, that finally their standardised physiological experiments, actually designed to give a baseline lethal dose in guinea pigs and rabbits against which serum therapy could be tested. It was only when we had these standardised global experiments that they could be compared like on like, and that's where Australian snake venom started to be seen as globally the most toxic, even more toxic than cobra venom.
May I follow that up, because it's so intriguing? Immunology, the science of immunology begins in Australia. It begins with snake bites. The Hall Institute, all of that edifice of first Nobel Prize in medicine that we get has to do with, ultimately, with snake bites. So it becomes a hugely important subject in Australia and therefore globally. Do you look, I'm sorry I haven't read your book, but do you look at the global politics of that, so to speak? All of a sudden Australian medical science gets on the map because of snakebite.
Yeah, so the question is about the importance of immunology and snakebite therapy in particular for the standing of Australian medical research. That's not this project, that's a previous project that I looked at, particularly at Australian medical science in the interwar years. And what I've tended to say is a couple of things. Firstly, if you go back and look at any Australian or Australasian medical, pharmacy, natural history or science journal from 1820 to 1920, somewhere in the first volume of any of those periodicals, you'll find reference to snakebite. So it always comes up as a pragmatic but also a scientific problem as well. There's periodic interest in the problem of snakebite. It seems to wax and wane about every 2 decades, and a large number of people in the 1860s and in the 1880s, early 1900s, the 1920s become interested in snakebite because I think they see it has popular appeal. They believe it's a practical problem that they can solve through the methods of modern medical science, whatever that means in 1865 or 1888. They don't always succeed, but certainly the work at the Walter and Eliza Hall Institute in the late 1920s, in conjunction with the Commonwealth Serum Laboratories, developed the first effective antivenines, but also in doing that pioneered the very first medical research grants administered by the Commonwealth, and in fact led to what we now call the National Health and Medical Research Council. So that paved the way to some extent for immunological research at the Hall Institute, although it was more, they focused more on pharmacology, and so Macfarlane Burnett, who came later, was a different strand of immunology, but he was certainly surrounded by that, which is what in the end led to his Nobel Prize in 1959, yeah.
Thanks very much for the presentation, it's very good. Just wondering, through your research, had you come across any reference or documentation on how the indigenous population dealt with snakebite? Because I'm sure they would have come across it.
Yes, it's a tricky one for two reasons. Firstly, my research focused on the way in which Europeans understood snakebite rather than attempting to understand indigenous ways of knowing. So anything I say about Aboriginal understanding of snakebite, or in fact of Maori understanding of katipo bites, comes through white sources, colonial sources. Broadly, the problem was diversity. You know, the enormous cultural diversity of Indigenous groups across Australia meant that there were a vastly different number of ways of knowing about venomous creatures. So there was almost nothing about spiders that I've ever seen, but in some areas, you know, snakes would be a totem animal. In others, they would be completely ignored and reviled and kept away from. So some groups would eat snakes, others wouldn't touch them. Some would have very clear cultural beliefs about which snakes were dangerous, but a group, you know, 50 kilometres away wouldn't think the same snake was dangerous. In terms of medical treatment, what we might broadly call medical treatment, there was also no consistency. Quite a number of groups would use a tourniquet and they would cut and suck the wound. And so Europeans coming in would say, well, of course they do that. That's what every rational person does. You know, it's just universal. So they partly dismiss Aboriginal knowledge by saying that's what we've known in, you know, in the Western world since antiquity. They might stuff possum fur into the wound and singe it. They might put it under running water as an attempt to sort of flush out the venom. What Aboriginal people never did, except on the very north coast, probably where they had contact with Macassan traders who therefore had contact with Dutch and Chinese medicine, nowhere else in Australia was any medicine ever taken in. It was all treated at the bite site, but it was very heterogeneous and therefore it was fairly easy to dismiss as well. So there were very few white or, you know, Europeans who cared what Aboriginal people had to say, except for Gerard Krefft, who published a lot of work on Australian snakes in the 1860s. He was one of the few who took Aboriginal testimony seriously, but it was very difficult. And in fact, there were some Aboriginal groups who believed that the snake itself didn't really matter because the snake was just a conduit for sorcery. So a little bit like having the bone pointed at you, that if a sorcerer had it in for you, they would send the agent, the snake as an agent of their ill will towards you. And there was no point doing anything because the snake didn't matter. It was the sorcery you had to deal with as well. So there was so much diversity in these views that I've tried to summarise it in my work, but again, I'm not versed in Indigenous ways of knowing. So that's a sort of refracted view. Yeah.
Thanks. In the introduction, you mentioned that you'd focused on some quirky scientist. Can we hear a bit more about that?
Bray. Yes. So James Bray is, last year I had a fellowship at the State Library of New South Wales, and I was looking at the papers and the life of a chap in Sydney called James Samuel Bray. Now, he was born a little bit before Tidswell in 1849, and he's an interesting contrast though. So Tidswell represents sort of a really modern, I guess in our sense of the word, a very modern outlook on science. You know, he's keen to adopt laboratory methods, he's keen to use microscopes, physiological apparatus, glassware. I mean, his descriptions, for instance, of siphoning off serum from his horse to make antivenom are quite detailed. James Bray was quite a different sort of person. He was what I tend to call an amateur naturalist in a much more early 19th century mode, except he was operating in the late 19th century. So he's a bit of a throwback in a way, but he ran a museum, so-called, in Sydney called Bray's Museum of Curios, and it stocked all manner of things from shrunken heads to animal bones to ethnographic artefacts, but he also had live snakes on display as well. And he would actually conduct experiments in his museum where he would have snakes biting cats, dogs and other animals, say goannas for instance as well, in the museum as part of a public display. The thing is that Bray craved scientific respectability, but effectively his museum was more of an emporium. Anything you came in, you could buy. You could come into his shop, it's probably about as big as this room. His museum was about the size of this room. And you could poke around and buy things if you wanted. And so he was always on the edge of scientific respectability and also on the edge of social respectability as well. So, for instance, he left his first, well, this is in 1876, he left his first wife and 3 children for a barmaid and had 2 children with her before he married her. So that gives you a sense in the late 19th century context of the sort of boundaries he was willing to skirt, I guess. So there was a sense in which his work was not respected scientifically, but also people who were respectable didn't want to associate with him as well. And I've seen that in his correspondence. So he, I guess finally coming back to his scientific methods, I think his work was quite an interesting contrast with Tidswell, because Bray would still look down a microscope at venom crystals, and he was trying to extract meaning from just looking at dried crystals and not going any further. He couldn't see how he needed to then use that dried venom, reconstituted in liquid, injected in measured quantities into an experimental animal that had been instrumented, and then extract from, you know, recording media like a kymograph, how he might read some sort of physiological message from that. He didn't do all the rest. He just looked down his microscope at the venom crystals and thought, what am I looking at here? And he couldn't ever get past it. So in some ways I feel sorry for James Bray, but he was very much, I think, a colonial relic at a time when people like Tidswell were embodying a whole new way of understanding the natural world. So sorry, that was rather a long discussion there.
Thanks for your talk. I just wondered, as a result of Tidswell's work, was there sort of a perverse national pride in the danger of our creatures, you know, along with spiders and sharks?
Yes, you start to see that emerging. So in the 19th century, Australian colonists were not particularly enamoured of their snakes in any way, you know, and anywhere, as you saw in one of those early pictures, anytime they encountered a snake, even if they were busy doing something else, they'd get off, grab a stick and chase it and kill it. They thought it was their patriotic duty to do so. It's only around this moment, around Federation in 1901, that you start to see Australians becoming proud of their dangerous creatures. And I think it's partly because of the work of Tidswell and Martin, who are now saying, look, on a global level, their venom is extraordinarily potent. And you know, by about 1914, Australian venoms were circling the world. They were going to India and to Britain and to the United States and to Switzerland, all sorts of places to be used as biochemical experimental agents. So you start to see a growth in this belief. Spiders weren't seen as dangerous, despite, you know, I think partly because of Tidswell's work, spiders weren't seen as dangerous in Australia until 1927. Quite specifically, redback and funnel web spiders were not believed to kill Australians until 1927. But this interest in snakes and this pride in how deadly they were coincides with a bigger movement that I guess has been called eco-nationalism, that says as the nativist movement, in other words, generations of people of European descent who've been born in Australia and their parents and their grandparents are born here, are increasingly identifying with the natural environment. And they become increasingly drawn to indigenous creatures to represent them. So the Australian coat of arms is not held up by a lion and a unicorn, it's held up by a kangaroo and an emu. And you see creatures like the kangaroo, the emu, the platypus, and the kookaburra all start to become really important emblems of Australian identity at the turn of the 20th century. Snakes, less so, but there is, I think, from that moment, a growing sort of perverse pride in just how deadly they are. It's around this period as well you start to see the early glimmerings of interest in marine stingers too. Sharks, I didn't study them as much because they're not venomous, but again, I always kept an eye out for them, because when you're looking for snakes in any index, you're also seeing scorpions, spiders, and sharks. And you know, I never saw a lot about sharks until again about the same amount, but also public bathing really only took off with relaxation of the laws in 1903, I think. So suddenly there were a lot more people swimming in our beaches from around the time of Federation. They were much more aware of sharks from that period. So I don't think they were so proud of them at that point. But yeah, it's a slow burn, I think, with the snake story. But certainly that pride in Australian indigenous creatures is very prominent from the 1890s and certainly from 1900 onwards. Yeah.
Peter, I just have one quick question. Can you clarify venom versus poison?
Yes, it's a good question, and it's one that gets mixed up a lot. But basically, venom is a modified saliva. So venom is something that's injected by a creature that comes effectively from its salivary glands and is injected with a bite, whereas poison is produced elsewhere in the body, usually as a defensive measure, but not always as well. So, for instance, if you think about the cane toad, for instance, it has sacs on its back that burst when the creature's bitten and they emit poison. So this is why the platypus, Tidswell in his book calls it venom in inverted commas some of the time, and other times he refers to it as platypus poison, and sometimes the inverted commas aren't there as well. Because it's produced in the creature and released through a duct and a spur, or like a sharpened nail, a little bit like a fang, there's always a lot of confusion about it, but I tend to refer to it as platypus poison rather than platypus venom. I'm happy to stick around and, sorry.
Are the female platypus harmless?
Yes. So, as I understand it, during early development, both sexes of the platypus develop these rudimentary structures on their rear legs, but in the females they don't develop into a spur. There's a slight sort of corrugation in their flesh at that point, but there's no sort of duct or anything that leads to venom production. So it's purely a male characteristic, and that's one of the things I'm interested in, because so much biology of platypuses has focused on what might be seen as the female characteristics, on whether they produce milk and whether they lay eggs, and I think it's this male characteristic that's been often overlooked. The echidna, which is also a monotreme, there's a rudimentary spur on the male, but there's not actually a connection between the spur and the duct. And so again, this has presented a sort of an evolutionary quandary. It's usually seen as an ancient structure that's disappearing, but there's no reason it couldn't be the other way around as well. So I like to throw out these challenges to biologists, because we tend to think that evolution is not directional, that that evolution is not heading in any particular direction or coming from any particular direction. But when you think about a structure like the spur on the platypus, which Tidswell and many others have said, why is it there? What does it do? Is it for defense? Is it for mating? Is it for grooming? Is it for climbing up riverbanks? Why would it only be in the males? Is it for combat between males? That's never been definitively answered. And so asking the same question, why is there also a similar structure in the echidna? It raises the same sorts of issues as well. Why would you have a characteristic that is partly present and partly not present as well? What does that mean to how we understand these primitive mammals? And I've said, why don't we ever think of them as advanced reptiles?
Okay, I think we might end there. Thank you very much.
Thank you. Thanks for the invitation.